All right, so when we left off Friday, we were talking about scatter plots and trend lines. You guys are ready to start class? So, as a reminder, while I'm taking attendance and doing work over there, you guys are supposed to start class before I start talking to you. You need to regulate yourselves and sit down and begin work. So Friday we talked about scatter plots and trend lines. We watched a video about the scientist who's studying the real life data of the methane that's being released where the glaciers are melting because of the organic material that's been frozen there as it thaws. It's releasing methane gas, which is changing the atmosphere. We also looked at a scatter plot that showed how both men and women are waiting longer to get married. Their ages are increasing. There's kind of a 2-year gap between the genders. We did a problem about movie theaters. We looked at the data when a movie's released over time, how less money is made because not as many people are going to see it. I think we did one about. It was something about biology, about height or something. Oh, it was about sugar. We did one about sugar and smoothies. And then there was another one. I can't remember. Anyway, we looked at like scatter plots, and we're still doing that. So number one, this is information you already know about scatter plots, about positive, negative, and no correlation. So if you want, you can just do one like this, or you can do a whole x and y axis that goes positive and negative. Most of them are just positive, positive, but let's take a look here. And a lot of times with scatter plots, it's real life data. Everything we looked at Friday, we were looking at real life data, so it's not just labeled the x and y axis. A lot of times it's labeled with like details about the data. But let's say we had to show positive. Oh, trigger. A little better. Okay. So positive flow data with a positive correlation starts low and goes high. Negative correlation is downhill. Okay, going down from left to right. And then no correlation at all. You just can't see any relationship. Just the stars in the sky. So we barely talked about that. It's in the book. I showed you in the book where it shows that. But that's something I feel like, and you guys said it last Friday. You already know. Positive, negative, no correlation. So I didn't dwell on it too much. Should be a bow work that you can do on your own. All right. So I am now going to give you a handout. I decided to print the handout so everybody would have a graph paper because we're going to plot data, we're going to draw a line through the data, and then we're going to write an equation for that line. Does anybody remember the rule for a line of fit? How do I know if a line of fit is a good line of fit? Yes, the same amount of data points above and below. And what we don't do is connect the dots. We're not connecting dots. We're drawing a straight line through data. right on this handout. Does anybody else need to take the quiz from last Thursday before break? Read it. What are we talking about? Yep. So this is like a work rate. I think the example here is filling leaves because that's something that you can do as a high school student. But work rate is like something that's kind of tracked among all industries. So this is like, do you guys know what part of business studies the way people work? What's that called? Management. So it's called human resources, right? So human resources will track people's work rates. Nurses, all of their work gets tracked really closely. How quickly can they go check on people in different rooms? Everybody has a work rate, to be honest with you. There's not an industry I can think of that doesn't. So we're starting with something applicable like filling leaves, but work rate. The people at Publix that are like checking people out, how quickly. I bet they know who's the fastest cashier person and who's the slowest. Yeah. You know someone fast? Yes, and then what they do, like, there's a lot of pressure in school. But what's wild to find out is there's a lot of pressure at work too. Like, how do you feel walking into Publix knowing that you're like middle of the line when it comes to like checking people out, but you treat people well and you're friendly, or maybe you're the slowest, or maybe you're the fastest, and you're really competitive. Like, it's important for us to go ahead and tell you, like, we're compared all the time in all the industries, so it doesn't just stop, unfortunately. You gotta just feel good about yourself, right? Yep. Like, let's say, for instance, she gets paid per bag. If you get paid per bag, you want to bag a lot of leaves. But what if you get paid per hour? You want to work slow. You want a full 8-hour day. Oh, sure, I could get this done in 5 hours, but if it takes me 8 hours, I'll get paid all day. So you work kind of slow. So for that reason, people a lot of times will pay, commission or per activity. But then what happens is people start to get sloppy. They fill up the bags. And maybe the bags are ripped or maybe they're too full. And so it's so complicated. Managers have to make the right decision. Do I want to pay per bag or do I want to pay per hour? Which do you think is better? Raise your hand if you think paying per bag is better. Raise your hand if you think paying per hour is better. I don't know. Do you think people are going to slow down if they get paid per hour? Some people say that the construction workers work more slowly because the longer they're out on that job, the more money they make. That's like one, of course they wouldn't say that. They have a lot of policy that makes them work slowly, but that complaint goes on in the business world. Not to pay per hour, but to pay per job. But something like construction, do you want someone building your house really fast because they get paid when the house is built? Or do you want to tell them, okay, you have 6 months to build a house, take your time and do it right? You want them to take their time and do it right. Whereas the person paying them, I want them just to do it really fast. Then they can sell more houses. Right, and then they're gonna get sued a year later. The walls are falling down. Okay, back at it. Fill in leaves. All right, so we gotta plot the points. So we got in 1 hour, that's 1, 3. These are your X's and these are your Y's. So 3 is kind of in the middle. The bags are going by 2s and the hours are going by 1s. They filled 4 bags, or I guess this is just Haley. 4 bags in 2 hours. 5? Oh, I messed that up. 2 hours for 4 bags. 3 hours for 5 bags. 4 hours for 8 bags. 5 hours for 14 bags. So this is non-linear. How was she able, based on this, 2 hours is 4 bags, that's like 2 bags per hour. So this should have taken 7 hours, but she got it done in 5 hours. Why do you think she got quicker as she went? Yeah. Maybe she found that out. What else might make her go quicker? Something about experience happens. Like maybe she figured out a good way to do it. Like when you start, you're slow, but then maybe you figure out the best rake, or maybe you figure out the best way to fill the bag. You get more quickly as you go. So there's something to be said for wisdom of waking reliefs. All right, now our task is to draw a line through the data. We want a same amount of points above and below. Use your ID. Use your ID if you don't have a ruler. It's okay if it's not perfect. Just approximately. Here we go. I'm gonna use a different color. Here we go. I'll try one more time. Let's try again. All right. Your line's gonna look different than mine. There's gonna be 30 different lines in the room because we're doing it by hand. As you move through mathematics, by senior year, you're probably going to calculate the most perfect line between these data. And that's called, well, you do that in statistics class. But you find out the standard deviation, how far the points are from the line, and then you calculate a perfect line of fit. And your calculators do that too when you get to like East Math or AP Calculus. For now, we're just drawing it by hand. Use the line of fit. It says to make a conjecture, but I want you guys to write an equation. If you use your line to make a conjecture, that means we're going to go, it says we want to know how many bags can she do in 7 hours. So I'm going to go from 7, I'm going to count up. And I'm going to say the line shows about 17 bags filled in 7 hours. That's what mine shows, but yours might show something different. So that's my prediction. Now I'm going to write an equation and find out for sure how many. So what are the steps to writing an equation? I'll put some steps over here. Let's pick 2 points on the line. Just any, you can pick any 2 points. It doesn't have to be a red dot. You find 2 points on your line. And then with those 2 points, find the slope. So slope formula, y2 minus y1 over x2 minus x1. I'm going to pick, I have a good point right here. It's like 4 comma 10. And then I'm going to pick, and that one's not really that good. Right here. Oh, that would be silly. How about 8 comma 20? I'm going to come way up here and I'm going to pick a point 8 comma 20. Oh, I feel like I can already see the slope. Now, I'm trying to find where the black line goes through 2 grid points. So I would accept this 1 comma 2. And then, yeah, this is good. 4 comma 10. So I'm not looking for red dots. Once you draw your line, you ignore the red dots. You're looking only at your line. You want an equation for the line, not for the red dots. So you pick points. I picked the orange points. Now I do slope formula. Is anybody doing their own points or is everyone using mine? Because I like to compare. If somebody wants to pick different points, then we can talk about how they're the same or different. Okay. My slope is 2.5. So a lot of times you're asked to interpret slopes. Interpret the slope, interpret the slope. I got 2.5, which would say overall, the slope shows Haley bags approximately 2.5 bags per hour. And that's on average for the whole data. In the beginning, she was slower than that. By the end, she was actually faster than that. So on average, it's about 2.5 per hour. Let's hear it. What points did you pick? Oh wow. Okay, your line's going a little bit lower. Cool. What was your slope? 2. Where did it 2? You got 2 too? And totally different points. Yeah, that's good. So your lines are lower than mine. Your slope is a little less steep. Okay, so now after you get slope, write an equation. Does anybody remember the form used for writing an equation? We'll compare our equation. How are we gonna write an equation? so far. Y minus y1 equals m times x minus 1. So there it equals 1. So my first point, x1, y1 is 410. My slope is 2.5. I'm going to plug that all in and write the equation. I'm out of room. Hope you guys have room. Okay. Oh, wait a minute. I'll let you guys distribute. Distribute 2.5, add 10. And we'll see what you get. Rewrite your equation. Go from point slope form to slope intercept form. Get y alone. My brother tried painting houses once on me. He was like, "Oh, I'm just not painting really quickly." He thought he was doing a great job. And he got fired. The guy said he wasn't like doing a good enough job. Like it was too sloppy. And his boss was like, "Slow down. It's not consistent." But he was like, "Tricky, right? Tricky finding that right place." What other jobs meant that happened? You go too quick and you actually get fired. Construction. What about mowing someone's yard? You try to mow that yard right, and then you run over the bush, and they're mad. So you had like 10 yards to mow that day. Yeah, painting. Mowing lawns, trimming trees. If, oh, yeah, good one. Because they go fast. They go fast too. The faster you are, and the barber, like the more people you see, the more money you make. But then if you get sloppy, nobody wants to go. That's a really good one. Okay, distribute 2.5. Add 10 to both sides. It actually cancels. And our equation is y equals 2.5x. That's supposed to be in here. Okay, so I don't really love my line compared to this equation. This would suggest that the y-intercept is 0, and mine like doesn't go perfectly through 0. How did yours work out, Ramsey? Did yours cancel out too? Oh, nice. And yours does hit 0. That's really good. What was your y-intercept? Oh, okay, so now they wanted to know about 7 hours. My prediction was 17 bags. Let's actually use the equation. So after you write the equation, use the equation to answer the question. So you're normally asked to plug in. So I'm actually going to plug in 7 and see how many bags would come out using that equation. And so my prediction was 17. What's 7 times 2.5? Let's just see. So that's 14 and 3.5. 17.5. So the equation says that Haley will get 17 and a half bags done in 7 hours. My graph, I kind of had to guess. I guessed 17, but actually when I look, it does look like it's pretty close to 18. So while the line shows 17 bags, the equation shows 17 and a half. All right, so when you go below that, it's about a pool leaking. The line's already done for you. You guys go ahead, pick 2 points. Write an equation in slope-intercept form. So do slope formula, do point slope form, and then decide how much pool is left after 40 minutes. Looks like this is 45 and the pool is empty. So 40, it looks like there's going to be 5 gallons left in the pool. But we'll make an equation and decide. So, does anybody study it? Well, why would it be inconsistent? Do you think water drains more quickly when it's the pool's, let's think about a big pool, like a YMCA pool. Is it going to drain more quickly when it's full or when it's almost empty? You know at the end when you can see the little tunnel or the little funnel? Is it going faster? I think gravity would suggest that it's going to go quicker to start, but I really don't know. Find slope. What points do you want to use? JC, you tell me one point you want to use about this baby pool. I wish we were talking about a big pool, but I mean, I can do a baby pool. Pick a point on the line. Is 535 on the line? No. Yeah, 035 is a great one. Let's do 035. X1, Y1. You call that 12? Oh, 2020. Yep, there's another one. Those are good points. X2, Y2. Yeah. All right, you guys, make an equation and then predict how much water is left after 40 minutes. Is it going to be ready to pick up and put away before the lawnmower comes by? They could just dump it, right? Well, you can't dump it on a concrete floor. You know who knows this? All the pool companies. They gotta drain the pool, come in, repaint the pool, wait for that to dry, then fill the pool up. They know all this data. Anybody in here? Nobody in the pool business? You gotta do the primer every day. Yeah, Veranador. They should have Veranador come and do this oil for us.
Air conditioning. Like air conditioning, so they mess with it. And we leave it hot for 8 days.
Yeah. You wanna do a good job on it. Miss Veranador, she owns the pool company. Maybe ask them about pools. So they're trying to be outside. Seems like an easy job in the pool. Who's got a pool guy? Comes in there and touches the pH balance and go clean it. And then they put more chlorine in.
Wish I did.
How's that for a job?
Did you make money?
No. You probably can't afford it. But if you own a pool company, you can. You just gotta, you know, believe in yourself.
That's what you're talking about.
It's a hustle, you gotta go quick. Like all this other, you know. Because how much are you paying for someone to pool up?
Crazy to see his dad, dude, he was like a police and stuff like that.
Yeah.
Yeah, and he was pretty well off. Yeah, so it wasn't like, it doesn't pay like crazy good, but it's like, you know, it's just a unique. That's another one.
Oh my gosh, do we have a negative slope this time? Yeah, it's a negative correlation, so. I got -3/4. Okay. Now, -3/4 is a great slope. What does that mean if I was to interpret it? It goes down 3 gallons every 4 minutes. That seems pretty fast. I wonder what type of nozzle's on this baby pool. Water leaks 3 gallons every 4 minutes. That's a bummer. All right, so now to get to our equation, we'll do y. We don't even need to do this. We can shortcut it. Does anybody know the shortcut? I'll tell you after we do the work. -3/4 x minus 0. Go ahead, rewrite it. Get y alone. Rewrite it. Wow, there it is. Alright, I did all the work. I rewrote the equation and I arrived at the y-intercept is 35. What shortcut could I have taken? I actually did extra work there. What could I have done differently? I didn't need to do the point slope form this time, but what? The 0. Yes, nice job. We already knew the y-intercept was going to be 35 because it has 0 with it. It was 0, 35. So I could have just put the slope with the 35 because the 35 is a y-intercept. So I could have shortcutted that problem. Anytime you know the y-intercept, you can shortcut. All right, so make a conjecture using the equation, not the picture, but the equation, about the amount of water left in the pool after 40 minutes. So the x-axis is time. So put 40 in for x, and let's see what we come up with. How much water's left, and then we can see if it matches the picture. I keep wanting to say prediction, but. All right, did anybody try plugging 40 in? So y equals -3/4 times 40 plus 35. Yeah, that's -120/4 plus 35. -30 plus 35. 5, which is exactly on the line. After 40 minutes, 5 gallons remain. At the YMCA, the lifeguards do the chlorine of the pool. No, they don't. They check it. I don't think they fill it. Anybody gonna be a lifeguard? They're always hiring. They're always hiring lifeguards. You could even be a lifeguard at the beach. All right, guys, flip this over, and you have the rest of class to finish the back of this handout.